let's go to the question number 19. In the reaction sequence, 1-chloropropane and reaction with silver cyanide, X is formed on treatment with hydrolysis, Y is formed. What is the Y compound Y? The option 1 is propylamine, option B is N-butane, option C is a 4-carbon, that is 1-amino-butane, and the option D is a 5-carbon. So now the reaction is actually a propyl bromide, a halide or a bromide is given, doesn't matter any halogen, but the reaction is here silver cyanide is taken. Silver cyanide has one point to discuss here. Unlike the sodium cyanide and potassium cyanide will have a clearly marked plus and minus spaces. Then the reaction, if you conduct with these two, what happens is the propyl with a cyanide comes, because the anion is cyanide wherein the minus charge is on the carbon, so therefore clearly cyanide groups are coming. However, you will get isocyanide also as a minor product. But in this reaction, because of the covalency between the silver and the carbon, it's not opened clearly, so therefore a nitrogen lone pair will take this advantage as a nucleophile, and the reaction happens to be a propyl isocyanide. This isocyanide on hydrolysis reaction, you are getting a breakage and you are getting the final answer is the N-propyl amine, that is the option A is the right answer. 20th question. In the given reaction, an ethylene is treated with the dichloromethane in presence of alcoholic KOH and heated, X is formed. X will be the option A is propane, option B is cyclopropane, option C is 1-chlorocyclopropane, option D is 1-chloro-2-ethyl cyclopropane. So here what happens, when ethylene is treated with several compounds, it undergoes an addition reaction with electrophilic addition reaction is the normal type of the reaction of ethylene. But here we have taken a 2 chlorines containing methane, we have taken treated with the alcoholic KOH. The K plus and the Cl minus and the OH and the H plus will be removed as a water molecule. So therefore it is undergoing a alpha elimination. Generally eliminating groups when 2 carbons are there, side by side elimination, that is beta, but in this case it is specifically HCl is eliminated from the same carbon, leading to giving the Cl side, Cl minus is gone, so therefore you will get a plus charge. This side electrons are left over, therefore a minus charge is formed. In fact, this type of compound should not be given written like this, because the same element with plus and minus is not the correct way of representation. In fact, we write this compound as a 1 hydrogen and the 1 chlorine with the minus charge, we show it as a pair of electrons in the same this one. This plus charge is shown as a vacant orbital. So this is called if 2 chlorines are there, we say dichloromethylene carbene. If both are hydrogens, we say methylene carbene. The carbene also, it is a singlet methylene carbene, and this acts as a pair is donating, therefore as a nucleophile. A vacant orbital is there, therefore it is an electrophile. So simultaneously it adds both the sides, so you will get a ring formation taking place. However, it is having the 1 hydrogen and the Cl, so therefore a cyclopropane ring is formed. This is what a singlet carbene if it is attached. If you wait for some time, it will become a triplet, and while adding the triplet, slightly stereochemistry also will be different. But right now the fresh reagent attacks as electrophile cum nucleophile. So the answer goes to the 1-chlorocyclopropane, a chlorine containing cyclopropane. It's a cyclo type of reaction. So answer C is the right answer. So let's go to the next question, 21. In the reaction sequence, the chloroform is treated with the atmospheric oxygen, that is air, in presence of a light. So therefore the reaction becomes into a X product. That X is treated with the benzene in presence of anhydrous aluminum chloride. Then the Y is formed. That is the, what is the compound Y he is asking. So the first reaction is chloroform undergoes oxidation actually. So the products formed here actually option A is a phosgene is there. So that is the X is actually phosgene, but he is asking why. So the option B is a benzoyl chloride, option C is a diphenyl ketone, option D is a benzaldehyde. So in the reaction what happens, the chloroform first of all becomes into the with atmospheric oxidation, slow reaction takes place. It will be oxidized to phosgene. And it also forms HCl, but we are not worried about this one. So, the phosgene is treated with the benzene in presence of the anhydrous aluminum chloride. So, the aluminum chloride holds the Cl minus and attacks as this one. So, the two benzenes are involved here. So, you will get a phenyl and twice Wedeltraft acylation reaction takes place. You will get the biphenyl ketone, that is the answer. So, answer C is the right answer. In the reaction sequence, CCl4 carbon tetrachloride treated with benzene in presence of anhydrous aluminum chloride, X is formed, X will be there. Now, here we have to check the options, which option is suitable actually, because the 4 chlorines are there, a benzene is treated. We may get an options different answers, but here the one option is all the 4 chlorines showing the Wedeltraft alkylation. The B is a 2 chlorine showing, and the C is 1 chlorine showing, the D is 3 chlorine showing. Here what happens, because of the big benzene, all the 4 cannot be undergoing this Wedeltraft alkylation, only 3 undergoes reaction. That means 3 benzenes react with 1 chloroform and giving the 3 phenyls a 3 sites. Because of the steric hindrance, the 4th side it is not reaction taking place, and here it becomes a chlorinated, that is a chlorine containing triphenyl methane will be the answer. So, the option D is the right answer. So, let us go to the next question 23. The chlorobenzene can be prepared from first here, that is starting material. He is asking to which compound is suitable. So, the compound A is a benzene diazonium chloride, option B is a benzaldehyde, option C is a benzene with acetic acid, and D is all of these. Actually, the compound C will give the benzyl bromide if the bromine is added, that is a Hansadeker reaction. Option B, benzaldehyde may not be dichloro compounds, you can prepare. Option A has got a right way to prepare the benzene diazonium chloride, can be prepared into the chlorobenzene in 2 ways. One is treating with CuX in presence of HX, that is HX is the reagent actually. This is the reagent and this is the catalyst, where X can be chloro, bromo and also cyanide. This is known as Sandmeyer reaction. Sandmeyer reaction. It can also be prepared in the same way by using already a chlorine is there in your diazonium chloride. So, therefore, just by add some copper powder and heat it. This is known as Gattermann reaction. Gattermann formylation reaction will leads to the same chlorobenzene. In the above reaction, the cuprous halide is the catalyst working here. If this salt is not there, it is the nucleophilic substitution. Otherwise, in catalyzed by the copper means it is a free radical substitution. Both the reaction leads to the chlorine. It's an excellent reaction known as Sandmeyer reaction or Gattermann reaction. So, the option A is the right answer. So, let us go to the next question 24. The question is phenyl chloride, that is chlorobenzene treated with the formaldehyde in presence of concentrated HCl and anhydrous zinc chloride. Compound A is formed which an oxidation with permanganate in basic medium and heated. A compound B is formed. What is compound B is asking. So, the options are given. A is a parachlorobenzyl chloride, B is a orthochlorobenzyl chloride, C is a parachlorobenzoic acid, and the D is a ordinary benzoic acid. Now, the reaction is here actually what happens here. When chlorine is there, already when chlorine is there, the reaction is with formaldehyde in presence of HCl and the anhydrous zinc chloride. Actually, this too is a combination of Lucas reagent, and HCl and this one will be forming a formoyl chloride, and it will be attacking on the benzene. It's an electrophilic substitution with electrophilic substitution, and the reaction takes place at a para position. So, giving a initially you will get a CH2OH, which is going to be replaced by the OH the OH is replaced by the, because Lucas reagent is there, it will become into the Cl. So this compound is oxidized. On oxidation will become oic acid. So finally what happens, a chlorine containing benzoic acid will be the answer. Here the chlorine, the question is also in view of the, we have to think that the what type of directing property it is. It is a minus I property, deactivating group, but it is a orthopara directing. So therefore electrophilic substitution takes place at para. After that the benzyl alcohol undergoes a halogenation, we will get a benzyl chloride. Benzyl chloride reoxidation will give the benzoic acid. That is answer A. The C is the right answer. The question here, this process is called chloromethylation. Chloromethylation. There is no specific name, but it is a process name. Methyl group is methylation, but chlorine containing methyl group is coming, so therefore chloromethylation. At a time both you are getting. In the given reaction, the product P is a 5-membered cyclopentane containing attached with again a bicyclo ring, that is cyclopropane, with 2 bromines and 1 type, which on treatment with the silver cation in presence of water, product P is formed. Answers are given, a cycloketone is given and a dihydroxy compound, option B. Option C is a ene with a ol is given, cycloene and a ol. Option D is a diol with a ene is given. So here the what happens when the reaction goes like this, we have a 3-membered ring with the 2 bromines, right? When it is treated with the silver cation, silver will take away the Br minus, okay? Then silver bromide is formed. You get a carbocation on this particular carbon, which opens up like this and then attacks here. So you will get a double bond formation here and you get a carbocation here. So what happens in between is a 6-membered ring containing a bromine here with a double bond. The next carbon, this carbon will have a positive. So which undergoes the hydration in presence of water, it is done. So therefore it is undergoing the hydration, that is the hydrolysis of this cation, water attacks and leaves the one OH. So finally you will get a cyclohexene with bromine and OH. This OH, this bromine also may undergo hydrolysis in general, but it's a vinyl type. So therefore it restores its existence and it is a resonance stabilized through the double bond. So therefore bromine will not be that easily hydrolyzed. So therefore you will get a vinyl bromide containing adjacent with the hydroxy. So therefore answer C is the right answer. Let's go to the next question, 26. Which of the following pairs will give DDT when treated with the constant sulfuric acid? DDT is a dichloro diphenyl trichloroethane, which is a insecticide, powerful insecticide, recently introduced into the syllabus also, specifically in the biomolecules where the insecticides and all that in that particular topic it comes. So the option A is a phenyl chloride and the acetaldehyde. Option B is phenyl chloride and a trichloroacetaldehyde, that is chloral. Option C is a phenyl chloride and a trichloro and hexachloroacetone. And option D is the phenyl chloride and the trichloro, one side, the other side is ordinary CH3. So this out of all these options, so DDT we know very well, it is prepared from the 2 chlorobenzenes undergo condensation with the an acetaldehyde derivative of the trichloro. DDT composition is slightly difficult, but once you see the preparation method, how it is prepared, it's 2 chlorines containing, that is benzenes with the hydrogens, and this one actually it undergoes a nucleophilic addition. The OH comes, OH is replaced by the negative part of this one. It's a nucleophilic addition followed by the substitution, but we can say it is a condensation reaction. As such, condensation, there is no role in the actual original reaction. So first nucleophilic addition followed by the substitution of the OH with the phenyl minus. So finally the compound leads to give a 2 phenyls linked to the carbon. This is called dichloro-diphenyl, and having a 3 chlorines, that is trichloroethane. dichloro diphenyl trichloroethane is known as DDT. It is prepared from the phenyl chloride and the chloral, that is the trichloroacetaldehyde. So option B is the right answer. So let's go to the question number 27. The IUPAC name of the freon 1,1 is asked. The option A is trichlorofluoromethane, option B difluoromethane, option C trifluoromethane, option D is the chlorofluorocarbons, that is here the specifically is asking one specific compound, that is freon 11. It is nothing but the CCl4 treated with the HF. So therefore a fluorine containing trichloro with a one fluorine containing compound is known as freon 11. So the answer goes to the A. Go to the question number 28. The freon 11 is prepared from which pair of the compounds? Option A is chloroform plus HF, option B is dichloromethane HF, option C is a tetrafluoromethane, that is a carbon tetrachloride and HF, option D is a chloroform, that is CH3Cl methyl chloride and the HF. So here it is a tetrachloromethane is taken, treated with the HF. By treating this monofluoro and trifluoro compound comes, this is called freon 1,1, and the HCl will be out. So therefore option C is the right answer. So let's go to the question number 29. Para-substituted benzyl bromide undergoes SN1 reaction with the nucleophiles and that is unnoticed, some nucleophile is given. A benzyl bromide with having a group on the para position, that group going on changing, the nucleophilic substitution reaction naturally changes. So the question is, arrange given 4 compounds in their decreasing order of reactivity for the above reaction. First one must be the more reactive one. So here what happens in the benzyl bromide, so in a SN1 reaction, first bromine will go, carbocation comes here, on the carbocation the nucleophile is going to attack. So when the nucleophile can attack means more stability, the stabilizing the carbocation will be the faster reaction here. So the group which influences the stabilization on the CH2 will be attacking intermediate. It is not the starting material. The starting material is stabilized, like in the carbonyl compound, so you get a carbocation which is a starting material. If the starting material is stabilized, the reaction delays. But this is after going the Br plus, you get a carbocation after step 1. After losing the Br, you get a carbocation as an intermediate. If the intermediate is stabilized or the final product is stabilized, the reaction will be fast. So therefore, more the stabilization of the carbocation will be the faster the reaction. So let us see which group will stabilize. So the C groups are methoxy group is there, and isopropyl group is there, and ordinary benzene and a methyl group. So best is the methoxy group. OCH3 will be the best group because OCH3 shows what a lone pair donation, therefore it is said to be a plus M group, strong activating group. Then comes the methyl group, CH3, with 3 hyperconjugations are there, which is the next group. 3 hyperconjugations are there, plus I effect also, that is the 2 operating systems are there. Then we go to the isopropyl group. Isopropyl has a bigger inductive effect, but the hyperconjugations only one is there, one hyperconjugation is there, and better plus I effect is there, but hyperconjugation is dominating, therefore we take isopropyl is a later, that is second preference is given. First preference goes to the methyl group here. So and then next comes to the ordinary benzene, that means substitution with only ordinary hydrogen. So therefore the answer C is the right answer. That is methoxy followed by the ordinary methyl, then isopropyl, then the hydrogen ordinary. So let's go to the next question, question number 30. Name the compound which will undergo SN2 reaction faster. Options are 1 chloropropane and 2 chloropropane, and a third option is 1 iodopropane option D is 2-iodopropane. All are propanes, but 2 degree, 1 degree, and the chlorine versus iodine is the thing here. But here the reaction is, in SN2 reaction, what happens? So the halogen is outgoing, a nucleophile is entering from the back side of this. So it is a SN2 reaction. In SN2 reaction, the nucleophile comes from the back side, that is rear side of the leaving, that is the X group, and as the groups, if it is smaller, the reaction will be the faster. That means primary will be the faster over secondary over the tertiary. As it becomes tertiary, SN1 reaction is encouraged, and SN2 reaction will become almost the ceases to 0 if it is tertiary. So in this case, only 1 degree, 2 degrees are given. A and C are 1 degree, both are more reactive than the B and D. Out of A and C, the iodine is the best outgoing. This, if halogen is iodine, the iodine will have outgoing property easily. So therefore, attacking and the outgoing both will take place faster. So therefore, answer C is the right answer. Next question, question number 31. Which of the following compounds will be most reactive for SN1 reaction? In SN1 reaction, the reaction passes through the carbocation. Let us see options. Option A is cyclohexane. Option B is a double bond with the chlorine, that is allyl chloride is there. Option C is again a cyclohexane with methyl, that is tertiary type of the compound. Option D is a allyl and also tertiary type of compound is there. Now, out of these three, the SN1 reaction is passing through the carbocation. So in this reaction, the general order is a benzyl type will be faster reaction over the allyl, over the alkyl. Within the alkyl, 3 degree, 2 degree, 1 degree. Then we have a vinyl type. Then we have the aryl type. The question is between the allyl type and the alkyl. Out of these two, allyl will be the faster. Within the alkyl, we have a 2 degree, 1 degree and 3 degree options are there. 2 degree and 3 degree options are there. So therefore, always again 3 degree with the allyl combination is there. The type of answer is D, wherein we have a double bond next carbon. This is allylic carbon, right? And we have a carbon also here, and a halogen is there. So this is a tertiary also as well as allyl. So this type of combination is a better combination than the other combination. So therefore, answer goes to the D therefore. So let's go to the question number 32. Which of the following compounds will give SN1 reaction in polar protic solvent? Again, SN1 reaction means the reaction should pass through the carbocation, and option A is a 2-chloro type, that is 2-bromo phenyl type, allyl and bromine is there. Option B is a primary, but it is a neopentyl type, which also preferable for the SN1 reaction. Option C is again allyl type with a bromo. So A, B, C all have got, each one has some credential. The first option has got a benzyl type, and B is a 1 degree it is actually, but the 3 alkyl groups, finally the group is so big, so therefore though it is 1 degree neopentyl type, 1 alkyl group is equals to 3 alkyl, so therefore it undergoes again a SN1 reaction, which gives a carbocation, then the reaction proceeds, though it is 1 degree, it is specifically. Even benzyl is a 1 degree. Benzyl is also 1 degree, but prefers to a carbocation because it is resonance stabilized. Allyl is also a 1 degree. Allyl is a carbon. This is also a 1 degree, but prefers SN1 reaction. All A, B, C have got, each one has got one speciality. They all prefer to the SN1 reaction. So therefore, answer goes to the answer D is the right answer. All the three. So let's go to the next question. 33 question. Which of the following compounds will give least substituted alkene as major product with alcoholic KOH? Actually, in the Sedgwick rule, the alkene with more substituted will be preferable. That is, in the least substituted means it is the anti-Sedgwick rule. So which of the following compounds prefers anti-Sedgwick rule is the question here. Here the option 1 is a halogen where we have a alpha, beta, gamma. On the gamma carbon we have a 4 alkyl groups. This type of question we have this is a alpha, beta, gamma. On the gamma carbon we have a 4th degree carbon. It is this type of option A is there. Option B is a tertiary compound is there. Option C is a 2 degree compound is there. Option D is a neopentyl compound. Specifically out of this A, B, C, D, so there is one principle that if the gamma carbon is quaterly substituted, then the obstruction of this hydrogen will be difficult. So therefore it undergoes a anti-Sergeff rule. So therefore the hydrogen comes from the exposed hydrogen is preferable one over a hindered hydrogen. This hydrogen is called hindered. So therefore the list substituted, that is a neopentyl one side and a alkene is formed. This type of alkene is a monoalkyl substituted. So therefore answer A is the right answer. Let's go to the next question, 34. Adiform test is not given by. Simple conceptual question. Adiform test is not given by means if it is a carbonyl compound, we must have a that is a methyl containing group. This side you can have any group, but the COCH3 should be there. If it is an alcohol is there, we should have a alcohol like this. One hydrogen can be there, any group it can be, but 2 degree 2 hydroxy, 2 methyl ketone. This type of functions are going to give the adiform test. Search for the options. Option A is acetone, option B is ethyl alcohol, option C is 1-propanol, option D is 2-propanol, of which only the 1-propanol will not give. It's a negative question which is not given by. So therefore acetone gives, ethyl alcohol, acetaldehyde, all will fulfill these conditions except 1-propanol. 1-propanol will have a 1-hydroxy. So this is not having this type of function. It is not neither the 2 degree nor it is a fulfilling condition. So therefore 1-propanol will not give the answer. So the answer C is the right answer. Go to the next question, 35. Which of the following compounds is used as a refrigerant? It didn't mention specifically what type of refrigerant it is. In general, the fluorochloro compounds are used as a refrigerants. Of which category? The option A is acetone. There is no fluorine, chlorine. Option B, tetrachloromethane. Option C is the tetrafluoromethane. Option D is the fluorinated, chlorinated compound. So therefore answer goes to the answer D. That is 2 fluorines are there and 2 chlorines are there. Fluorochlorocarbons are specifically used as a refrigerants. So option D is the right answer. Question number 36. In which of the following conversions the reagent is PCl5? Usually PCl5 is a halogenating agent and it is also can be used in the Beckmann rearrangement and so on as a Lewis acid, as a catalyst can be used in some cases. Let us see the question here. Option A is conversion of ethylene to ethyl chloride, that needs actually HCl. Option B, methyl cyanide to methyl chloride. Option C, ethanol to ethyl chloride. Option D, acetylene to the vinyl chloride. Option C is OH converting into the Cl, that is either in the alcoholic OH or in the carboxylic acid OH. Both can be, these hydroxy groups can be converted with PCl5 into RCl. In this case you will get RCOCl. Both are achievable by the PCl5. So the option C is the right answer there. Let's go to the next question, 37. In the given reaction, a compound is treated with the hydroxy group and you got a hydroxy group containing compound, but the starting material is an optically active compound and the answer is also optically active, but it is opposite configuration, that is the compound undergone a 100% inversion in the configuration, and this type of inversion you expect in the one of the following reaction. So here is an example of he is asking. The first one is a substitution electrophilic with bimolecular, substitution nucleophilic unimolecular, and a substitution nucleophilic bimolecular, substitution electrophilic unimolecular. In this reaction it is a substitution nucleophilic, specifically inversion in configuration 100% is always takes place in the SN2 reaction. In SN1 reaction, carbocation, and you will get D and L mixture formation. It is optically just inversion is asked here. So therefore it goes to the SN2 type of reaction. So the option C is the right answer. Which of the following will not form iodoform test with iodine and the base OH minus? Ethanol, option A. Option B, ethanol aldehyde. Option C, isopropyl alcohol. Option D, benzyl alcohol. Ethanol, that is option A, is ethyl alcohol that gives the reaction as under the exception case. Acetaldehyde also gives under exception case. And the third one is isopropyl alcohol. As per the norms, it is 2-hydroxy and 2 degree. So therefore it gives. And both A, B, C will give, but will not give means benzyl alcohol is the last option. Benzyl alcohol is a 1 degree and it's not undergoing the reaction of iodoform reaction. So the option D is the right answer. Let's go to the question number 39. The question is, two isomers of haloalkenes A and B have molecular formula C5H9Cl. So this A and B have the same molecular formula, that is isomers. A gives optically inactive compound while B gives optically active compound in hydrogenation reaction. The two isomers respectively are, that is when halogen is removed in the reduction process, both the compounds are converted into their respective reduced forms. Let us see what is the criterion here. The optical activity means both have C5H9Cl. That means there are 5 carbons are there existing A and B. Both are alkenes. There is one double bond in both the cases, and this double bond is hydrogenated. Hydrogenated means the compound will become into a saturated. It's not a reduction of the alkyl halide, but it is a hydrogenation. Therefore double bond will become into the unsaturated site, will become into saturation. So the A is that is if the compound is originally like this, one side alkyl, one side is alkene type. If a halogen is there, this fulfills the formula C5H9Cl. So this is originally optically active. Let us say when this is reduced, it is going to become optically inactive compound. That is both the sides ethyl will come now. So one of the compound where he says this is optically inactive, answer is formed. From which compound he says in optical compound? A gives optically inactive compound. So A must be this one. A gives optically inactive. There is no optical activity in this case. And B gives optically active compound. That means the position of the compound may be in a different way. Like for example, if the B is like this, if the chlorine is here, even on reduction also you will get optically active compound. This is originally optically active. Even after the reduction of the double bond also you will get still it is optically active compound. So this may be the one of the answer. B is originally optically active. After reduction also you have a optically active center is there. So therefore the answer A, 3-chloro-1-pentene. 3-chloro-1-pentene is A, and 4-chloro-2-pentene. 4-chloro 1, 2, 3, 4. 4-chloro-2-pentene. It can be the double bond here or it can be here. So either way it is also okay, makes no difference. The double bond is converted. So that is in both the cases that is option A. Answer A is the right answer. Let's go to the 40th question. Next, the conversion of 2,3-dibromobutane to butene with zinc and ethyl alcohol. Option A is redox reaction. Option B is alpha elimination. Option C is beta elimination. Option D is both beta elimination and redox reaction. The reaction is actually a dibromobutane. Let us see the question here. It's a 2,3-dibromobutane and treated with the zinc. The zinc takes away the 2 halogens. So it is a elimination reaction forming the 2-butene. So elimination is right. Specifically with reference to the bromine, it is alpha and beta. So the beta bromine is removing with reference to the first bromine. So therefore it is a beta elimination. and also it is a removal of the bromine, so therefore it is an oxidation reaction, and zinc is undergoing reduction, therefore it is a redox also. So the reaction, therefore it is the option D, that is both beta elimination and also redox reaction. Answer D is the right answer. So let's go to the next question, 41. Iodoform unheating with KOH gives acetic acid, option 1. Option B is the potassium salt of acetic acid. Option C, potassium formate. Option D is only formic acid. Iodoform is nothing but a 3 iodines containing methyl iodide, right, which on reaction with OH minus, all these halogens, an intermediate you can show like this 3 OHs will come, which eliminates the water molecule to give the formic acid. Formic acid, because the OH is the potassium hydroxide is there, therefore a neutralization taking place, you will get a H plus removal and you will get a HCOOK. So that is the right answer. So let us see the option C is the potassium formate is the answer. Let's go to the 42 question. Which of the following two isomers A and B will undergo SN1 substitution with iodine, an isotopic iodine 128 faster, and why? In this reaction, compound A and B are the isomeric, both are very close reaction. Here a tertiary butyl group is added so that the ring will not undergo flipping, and in one compound the hydrogen is axial and the iodine is in the equatorial. This is 127 original iodine. This is treated with the iodine 128, that is the labeled iodine. So this iodine will go, another iodine is coming in this reaction. The other compound is also very much closer. In this reaction, the axial is iodine, this is axial is iodine, and equatorial is the hydrogen. And in this case also a tertiary butyl group is added here so that the flipping will not takes place. So the reaction already in the original compound A, the iodine is equatorial, it is a stable one, and the reaction when it is axial, actually the reaction will be faster there, and the answer will come after a reaction. In this reaction, answer will have the iodine in the equatorial. In this answer will come the iodine into the axial, which is a less stable, isn't it? So the stable to unstable is not the favorable reaction, but it is a axial, it is a less stable. Less stable will have a reaction which is a more stable equatorial, that is iodine will become into equatorial, it is the inversion. In a SN2 reaction, 100% inversion taking place. So therefore in SN1 reaction, through carbocation reaction taking place. So therefore the final answer will have a stable product. Less stable will become into the stable product. So therefore option A, the second compound will undergo the fast reaction, that is answer B will be the undergoing fast reaction. So the option D, if you read it, B will react faster because it is less stable than A. The transition state for the both the reactions are of course the same energy, and it will yield the more stable product, that is an axial, if it is converted to equatorial, that is the product will be the more stable product. So therefore answer D will be the right answer.